Friends, now let us learn divisibility for even divisors. Let us learn to check the divisibility of a given number by the divisors containing 2, 4, 6 and 8 in its units places. Let us read the algorithm first. Step number 1. Find the osculator for given divisor. Observe the divisor and find, that is calculate osculator for given divisor. Number 2, step number 2. Osculate given number by osculator. This process is called as osculation process. Step number 3. If last osculation number, that is osculation result, is 0 or multiple of divisor, then given number is divisible by given divisor, otherwise not. Finding quotients and remainders will be best understood while explaining working steps. To find quotient and remainder is extremely easy, but it is best understood while learning or while the working steps are being explained. Let us first learn how to calculate osculator for the divisors containing 2, 4, 6 and 8 in the units places. In this topic also there are two osculators. We will find two osculators, positive osculator and negative osculator. So we will learn how to calculate positive osculator for the divisors containing 2, 4, 6 and 8 in the units places, and we will learn to calculate negative osculator for those divisors. Now, important note, use positive osculators for the divisors containing 8 in the units place and use negative osculators for the divisors containing 2 in the units place. Now friends, in the previous topic, that is divisibility for odd divisors, we calculated osculators. We calculated positive osculators for the divisors which contain 9 in its units place, and we calculated negative osculators for the divisors which contain 1 in its units place. Just like that, we are going to calculate positive osculators for the divisors which contains 8 in its units place, and we will calculate negative osculators for the divisors which contains 2 in its units place. Now friends, let us learn what is positive osculator. Now suppose we have a divisor 18. This 18 is divisor. Okay, this 18 is divisor. Now there is 8 in the units place of divisor 18. That means we are going to calculate positive osculator for this divisor. Now how to calculate positive osculator? See, write 18 and add 2. See, write this 18 which is divisor and add 2 to this 18. Now why this 2? Because this 2 is nothing but, see, this 2 is twice the ekadhik. See, this 1 is ekadhik. How do we calculate ekadhik? See, for example, if it is 19, we add 1 to this 19 and we get 20. Okay, 20 is ekadhik of 19. 20 is one more of this 19. We have calculated this 20 by adding 1 to this 19. Just like that, when we calculate positive osculators for even divisors, especially for such divisors which contains 8 in its units place, then we add twice the ekadhik. See, this 2 is twice ekadhik. See, this is ekadhik, this is twice ekadhik, 2 times ekadhik. We get 20. Now neglect this 0, write 2. This 2 is positive osculator for given divisor 18. Second example, if it is 38, what to do? 38 is divisor. Write this 38, add 2 to this 38, you get 40. Okay, now neglect this 0 and write 4 only. This 4 is positive osculator for given divisor 38. Third example, if it is 58, add 2 to this 58, you get 60. Neglect this 0 and consider this 6 only. This 6 is positive osculator for given divisor 58. This is divisor. What is this 2? This 2 is 2 times ekadhik. When we calculate ekadhik, we add 1. But while calculating positive osculator for the divisor containing 8 in the units place, we add 2, that is twice ekadhik. Second example, if number is 16, divisor is 16. How to calculate positive osculator for the number 16, for the divisor 16? See, rule is rule. We want 8. We want 8 in the units place to calculate positive osculator. Now let us convert this 16 into such number, into such product which will contain 8 in its units place. And to convert this 16 into such number, let us multiply this 16 by appropriate multiple, suitable multiple. So which multiple we have to use here? See, to get such product which will contain 8 in its units place, see, I think 3, because 6 3s are 18, 3 1s are 3 plus 1, 4, that is 16 3s are 48. Yes, we got 8 in the units place. Okay, now let us add 2 to this 48. Okay, you get 50. Now neglect this 0 and write 5 only. This 5 is positive osculator for given divisor 16. This 5 is positive osculator for given divisor 16. If the number is 26, there is 6 in the units place. But if we want to calculate positive osculator, then we will have to convert this 26 into such number, into such product which will contain 8 in its units place. Now think friends, how to convert this 26 into such number which contains 8 in its units place? Just multiply this 26 by suitable multiple, which is 3 here. So 26 3s are 78. Now we have got 8 in the units place. Now let us add 2 to this 78 and get 80. Now forget, neglect, drop this 0 and consider this 8 only. Write this 8, and this 8 is positive osculator for given divisor 26. 46. Divisor is 46. What to do? Just multiply this 46 by 3 to get such number which contains 8 in its units place. 3 6 are 18, 3 4s are 12 plus 1, 13. Correct? Now to this 138 add 2, you get 140. Okay, neglect this 0 and write 14 only. This 14 is positive osculator for given number 46. Correct? If the divisor is 34. How to calculate positive osculator for given divisor 34? Simple, same rule. We want 8 in the units place. Then only we are able to calculate positive osculator. Now let us convert this 34 into such number which will contain 8 in its units place. 34 multiplied by 2 gives us 68. Now we have 8 in the units place. Now to this 68 add 2, you get 70. Correct? Neglect this 0 and write 7 only. This 7 is positive osculator for given divisor 34. 84. Number is 84. How to calculate positive osculator for 84? See, 84 multiplied by 2 is 4 2s are 8, 8 2s are 16. Correct? 168. Now we have got such number which contains 8 in its units place. Now let us add, see, now let us add 2 to this 168, which gives us 170. Neglect this 0 and write 17 only. Correct? This 17 is positive osculator for given divisor 84. This 17 is positive osculator for given divisor 84. Correct? Next example, if number is 12, this is divisor. Okay, if divisor is 12 or such number which contains 2 in the units place, same rule. See, convert this 12 into such number which contains 8 in its units place. To get such number from this 12, we will have to multiply this 12 by 4, okay, which gives us 12 4s are 48. We have got 8 in the units place. Now let us add 2 to this 48, we get 50. Neglect this 0 and consider this 5 only. This 5 is positive osculator for given divisor 12. If the number is 72, this is divisor. How to calculate positive osculator? We need 8 in the units place. So let us multiply this 72 given divisor by suitable multiple 4, which gives us, and 7 4s are 28. Correct? 4 2s are 8, 4 7s are 28. Now add to this 288, add 2 and you get 290. Neglect this 0 and write this 29. This 29 is positive osculator for given divisor 72. So friends, this is how we calculate positive osculator for given divisor which contains 2, 4, 6 and 8 in its units place. Understand one thing, you need 8 in the units place of a divisor to calculate positive osculator. And if you are given such divisor which don't contain 8, then convert that divisor, that number, into such number by multiplying that divisor by some suitable multiple and get or calculate such product which contains 8 in its units place. So this is how you calculate positive osculator for the divisors containing 2, 4, 6 and 8 in its units places. Now friends, let us see how to calculate negative osculator for given divisor. Now friends, let us learn what are negative osculators for even divisors. Friends, just before a while we learned how to calculate positive osculators for even divisors. See, to calculate positive osculator, we need 8 in the units place. And to calculate negative osculator, we need 2 in the units place of divisor. For example, the divisor is 12. See, write this 12 and subtract twice a canune from 12. That means subtract 2 from this 12. You get 10. Neglect this 0 and write 1. This 1 is negative osculator for given divisor 12. If it is 42, see, write 42, subtract 2 from 42, that is given divisor, and write 40. You get 40. Neglect this 0 and consider this 4. This 4 is negative osculator for given divisor 42. If it is 82, 82 minus 2 is equal to 80. Neglect this 0 and consider this 8. This 8 is negative osculator for given divisor 82. Now friends, what is this 2? This 2 is twice Akanon. See, how is it? See, when we calculate Akanon, see, this 12 is that 12, okay. So when we calculate Akanon of this 12, then we subtract 1 from this 12 and we get 11. Subtract 2 times Akanon from 12, then we get, see, 2 times 1, subtract this 2 from 12, we get 10. So this 2 is 2 times Akanon, okay. So now if the divisor is 14, how to calculate negative osculator for the divisor 14? Rule is rule. To calculate negative osculator, we need 2 in the units place of a divisor. So convert this 14 into such number which will contain 2 in its units place. Simple. How to convert this 14 into such number then? See, multiply this 14 by 3, which gives you 14 3s are 42. Correct? Now we have got 42 which contains 2. Now subtract 2 from this 42, you get 40. Neglect this 0 and write 4. Okay, this 4 is negative osculator for 14. If it is 24, apply same rule. Convert this 24 by multiplying this 24 by such suitable multiple, which is of course 3, to get such number which contains 2 in its units place. 24 ones are 24, 24 twos are 48, 24 threes are 72. Correct? Now subtract 2 from the 72, you get 70. Neglect this 0, write 7, and this 7 is negative osculator for given divisor 24. Now if it is 16, what to do? Convert this 16 into such number which contains 2 in the units place. So multiply this 16 by 2. You get 16 twos are 32. Subtract 2 from this 32. You get 30. Neglect this 0 and write 3 as it is. And this 3 is negative osculator for 16. Divisor 16. If it is 26, multiply this 26 by 2. You get 26 twos are 52. Correct? Yes, 52. Subtract 2 from this 52. You get 50. Neglect this 0 and write 5 as it is. Okay, this 5 is negative osculator for given divisor 26. If it is 18, okay, let me change color. If it is 18, how to convert 18 into such number which contains 2 in its units place, because we want 2 to calculate negative osculator. So 18 multiplied by which multiple you have to multiply this 18 to get such number which contains 2. I think it is 4. Correct? 72. Now we have got 72. Subtract 2 from 72, you get 70. Neglect this 0 and write 7 as it is. This 7 is negative osculator for given divisor 18. If it is 88, given divisor is 88, then convert this 88 into such number which contains 2 in its units place. So multiply this 88 by 4, so that you will get such number. So 4 8s are 32, carry 3, 4 8s are 32, 2 plus 3, 35. Correct? Now subtract 2 from 352. You get 350. Neglect this 0 and write 35 as it is. And this 35 is negative osculator for given divisor 88. So friends, I hope that you have understood what are positive oscullators and negative oscullators for even divisors. Please understand friend, if you want to calculate, or in other words, if it is 8 in the units place of even divisor, calculate positive osculator by adding 2 to that number. And if it is divisor, even divisor containing 2 in its units place, subtract 2 from that divisor and calculate negative osculator. See friends, now let us discuss some important point. See, let us write divisor here, and let us write positive osculator here, and let us write negative osculator here. 18, 16, 14 and 12. Let us calculate positive osculators for these 4 divisors and write here. See, positive osculator for 18. 18 plus 2 is 20. Neglect 0 and write 2. This 2 is positive osculator. 16. See, 16 multiplied by 3 is 48 plus 2 is 50, that means 5 is positive osculator for 16. 5. 14. What about 14? 14 multiplied by, to get 8 in the units place, that is 2 plus 2, that is 30, that means 3. Okay, so 3 is positive osculator for 14. What about 12? 12 multiplied by 4 is, add 2, you get 50, neglect 0, that means 5. Now let us calculate negative osculators for these 4 divisors. First divisor 18. Let us calculate negative osculator for this 18, but we need 2. So multiply this 18 by 4. 72 subtract 2, it is 7. That means it is 7. If it is 16, 32, that is 3. Okay, right. If it is 14, that is 4. And if it is 12, then just subtract 2 from 12, you get 10, neglect 0 and write 1. Observe this table carefully. Divisors 18, 16, 14 and 12. Positive osculator for 18 is 2, negative osculator for 18 is 7. Positive osculator for 16 is 5, osculator for 16 is 3. Positive osculator for 14 is 3 and negative osculator is 4. Positive osculator for 12 is 5 and negative osculator is 1. It means friends, when divisor contain 8 and 4, see, divisor contains 8 and 4 in the units place, let us calculate positive osculator. And if divisor contains 2 and 6, then we will go for negative osculator. So friends, I hope that you have understood how to calculate positive and negative osculators for even divisors. Now let us learn osculation process. Let us learn to osculate given dividend by osculation process. Friends, we have understood how to calculate positive and negative osculators for even divisors. Now let us understand osculation process. Okay, so let us solve these 12 examples and understand this osculation process. See, use osculation process to test the divisibility of following numbers and also find quotients and remainders. Let us first test the divisibility, and after that let us find quotients and remainders. Okay, so let us solve first example. 9648 divided by 18. Let us first read important note. Use positive oscullators for divisors containing 8 and 4 in its units places, and use negative oscullators for the divisors containing 2 and 6 in its units places. Okay, let us start osculation process. D is for dividend. Okay, in this row we have written given number, that is dividend. In this row we will write osculation result, and in this row we will get quotient digits. Observe divisor 18. There is 8 in the units place. It means we have to calculate positive osculator for given divisor 18. How to calculate positive osculator? 18 plus 2 is equal to 20. Neglect this 0, drop this 0 and write 2 as it is. Okay, this 2 is positive osculator. Correct. Now let us osculate given number 9648 by positive osculator 2. We start osculation process from left side. So the step number 1. Step number 1. Consider first digit, leftmost digit, which is 9. Divide this 9 by positive osculator 2. You get quotient. 2 4s are 8. Quotient is 4 and remainder is 1. So write first quotient digit below first digit 9 and write remainder 1 as a prefix to next digit in the dividend, which is 6, and now read this as 16. Read this as 16. This is 16. Now step number 2. Let us calculate osculation result. First osculation number. So 16. You cannot divide this 16 directly by 2. For that you have to calculate osculation result. And you can divide that osculation result, osculation number, by this 2. How to calculate osculation result, osculation number? See, 16 plus, as this is positive osculator process, so add. Now what to add? 2 times last quotient, that means first quotient, which is 4, quotient digit. Okay, so 16 plus 8 is 24. This 24 is first osculation number, first osculation result. Now to this 24 divide by 2, which gives us quotient 12. See, 12 2s are 24 and remainder obviously 0. So write quotient 12 below osculation number 24, first osculation number 24, and write remainder 0 as a prefix to next digit, which is 4. Now read this as 4. Step number 3. You cannot divide this 4 directly by 2. For that you have to calculate osculation number. So 4 plus, how to calculate osculation number? 2 times, to this 4 add 2 times last quotient, 2 times 12, which is equal to 4 plus 24. 12 2s are 24. 24 plus 4, 28. Okay, now this 28 is second osculation number. Now 28 divided by 2 gives us quotient 14 and remainder 0. So write quotient 14 in the quotient area and remainder 0 as a prefix to next digit, last digit, which is 8 in the dividend. So step number 4 is 8 plus, see this 8, okay, this 8 plus 2 times last quotient, that is 14, which is equal to 8 plus 14 twos are 28, 28 plus 8 36. So this 36 is last osculation number, and write 36 below last digit. Write last osculation result below last digit in the dividend. Now friends, observe this 36. This 36 is 2 multiple of divisor 18. See, this 36 is 2 multiple of divisor 18. Okay, so quotient in this part is 2. We will use this quotient 2 later, but first of all let us find quotient. What are quotient digits? First quotient 4, second 12, third 14. So these last two quotients contains extra digits. So let us pass extra digit to its immediate left side, and always do this process starting from right side, right to left. Okay, so pass this one to its immediate left. So write 4 and add 1 to this 12. It is 13 now. Write 3, pass this extra digit to its left, which is 5. Okay, so quotient is 534. Now add to this 534 quotient 2. Let us add, which gives us 536. So 536 is final answer. So friends, given number 9648 divided by divisor 18 is or is equal to 536. So I hope that you have understood osculation process for even divisors using positive osculator. So let us solve next example. Please pause video and write these 4 steps, and also write this, okay, dividend osculation results and quotient. Okay, and also write how did we calculate positive osculator. Second example, 1,83,728 divided by 38. So there is 8 in the units place. So let us calculate positive osculator. Write 38, add 2, you get 40. Now neglect this 0 and write 4. This 4 is positive osculation, and let us osculate given number by positive osculator 4. Correct? So first step, starting from left side, consider leftmost digit 1. Divide this 1 by 4. Not possible because this 4 is greater than 1. So join second digit 8 to this 1. Now you have 18. Divide 18 by osculator 4, which gives us quotient is 4 4s are 16. Okay, and remainder is 2. 18 minus 16 is 2. Okay, so write quotient 4 and see, write quotient 4 in the quotient area and write remainder 2 as a prefix to next digit, which is 3. Now read this as 23. Now friends, you cannot divide this 23 directly by 4. For that you have to calculate osculation number and write that osculation number in the row of osculation result. So step number 2 is 23. As this is positive osculation process, so plus add. What to add? 2 times first quotient digit, first quotient, last quotient. Instead saying first quotient, let us say last quotient. So 4. Last quotient is 4. So 23 plus 2 4s are 8. 23 plus 8 is 31. This 31 is first osculation number and to be written below 23. Now let us divide this 31 by osculator 4, which gives us quotient. Quotient equal to 4 6 are 24, 4 7s are 28, 4 7s are 28, yes, and 4 8s are 32. That means quotient is 7 and remainder is 3. 4 7s are 28, 31 minus 28 is 3. So write quotient 7 in the quotient area below first osculation number 31 and write remainder 3 as a prefix to next digit in the dividend. Now read this as 37, not as 3 and 7 separately. Okay, read this as 37. Correct? Now step number 3, 37 plus what to add? 2 times last quotient digit or last quotient. That means 2 multiplied by 7. 2 times last quotient. Okay, so how much? 37 plus 14. Okay, so 37 plus 10, 47 plus 4, 51. Now write this 51 as a second osculation result and write this below 37. Now 51, divide this 51 by osculator 4, which gives us 12 4s are 48, yes, and 51 minus 48 is 3. So quotient is 12 and remainder is 3. So write 12 in the quotient area below 51 and remainder 3 as a prefix to next digit, which is 2. Now read this as 32. Correct? So friends, please pause video and write these 3 steps. Okay. Step number 4, 32 plus what to add to this 32? See, we are going to find third osculation result. Okay, so to find third osculation result, 32 plus, see this 32 plus 2 times last quotient, that is 12, which gives us 32 plus 24. 12 2s are 24. That means 32 plus 20, 52 plus 4, 56. Okay, 56. So write 56 below 32. Now divide this 56 by osculator 4, which gives us quotient 14. 14 4s are 56, correct? And remainder is 0. Now write this 14, quotient 14 below 56 and remainder 0 as a prefix to next digit, last digit, which is 8. Now read this as 8 and let us find last osculation result in the step number 5. So step number 5, 8 plus 2 times 14. See friends, multiplying last quotient by 2 is important. See, so 2 times 14 is 8 plus 28, correct? 8 plus 28 is 36. We write here 36, write 36 below 8. This 36 is last osculation result and to be written below last digit in the dividend, which is 8. Now see friends, See this 36 last osculation result. This 36 is not divisor or multiple of divisor, and even we didn't get 0 here. It means that given number 1,83,728 is not divisible by given divisor 38. So this number is not divisible. Now let us find quotient and remainder. So let us write quotient here. Let us write all the quotients as it is first. 4, 7, 12 and 14. Now friends, observe these quotients properly. Last, see, right sided two quotients contain extra digits. See, and what are extra digits? How do we find extra digits? See, except units place digit. See, except units place digit, higher place digit or digits are considered to be extra digits. So here 1 is an extra digit. So let us pass this one to its immediate left and add this one to this 12, which becomes 13. Here also we have extra digit. Pass this one to its immediate left, and that way passing means adding. Okay, so 7 plus 1 is 8. So write the quotient 4, 8, 3 and 4. Correct? 4, 8, 3, 4. 4,834. Quotient is 4,834, and this is remainder. Friends, please understand this important thing. If given number is not divisible, given number is not divisible by given divisor, then in the last osculation result, in the last osculation number, you find remainder. And if it is divisible in this part, that means last osculation result, you find quotient. I will repeat, if the number is divisible, then in this part means last osculation result. If the number is divisible, then you find here quotient, and if it is not divisible, then last osculation result is considered to be remainder. So 36 is remainder. Remainder is 36. Correct? Now friends, if you are doubtful of this answer, then let us check if our answer is correct or not by applying Bijanka method, digital root method. See, what is division algorithm? Dividend. See, dividend equal to divisor multiplied by quotient plus remainder. What is dividend here? Let me see the dividend here first. 18, 37, 28. Okay, 18, 37, 28 equal to, should be equal to, what is divisor? Divisor is 38 multiplied by what is quotient? 4834. 4834 plus what is remainder? Remainder is 36. Okay, now apply Bijanka method. Let us calculate Bijanka. Okay, let us calculate Bijanka of these numbers. Bijanka of dividend, Bijanka of divisor, Bijanka of quotient and Bijanka of remainder. Bijanka means digital root. So let us calculate. 1 plus 8, 9, leave it. 3 plus 7, 10. Okay, 3 plus 7, 10. 10 plus 2, 12. 12 plus 8, 20. 2 plus 0, 2. Bijanka of this number is 2. 8 plus 3 is 11. 1 plus 1, 2. Multiplied by 4 plus 8, 12. 12 plus 3, 15. 15 plus 4, 19. 1 plus 9, 10. 1 plus 0, 1. Plus 3 plus 6, 9. Okay, so 2 equal to 2 multiplied by 1, that is 2 plus 9, that means 2 equal to 11. 1 plus 1, 2. Okay, so verified and we are correct. Example number 3. 5,74,464 divided by 88. 5,74,464 and divisor is 88. Now 8 in the units place of divisor. So let us calculate positive osculator. 88 plus 2 is 90. Neglect this 0 and write 9 as it is. Okay, this is positive osculator. Now let us osculate given number. Let us osculate given number by this positive osculator 9. So step number 1, starting from left side, consider digit first, 5. 9 is greater than 5. So join this second digit to this 5. We have 57. 57 divided by 9, which gives us quotient 9 6 are 54. And remainder is 57 minus 54 is 3. So let us write quotient 6 below 57 and write remainder 3 as a prefix to next digit in the dividend, which is 4. Now read this as 34. Okay, read this as 34. Now let us find first osculation number. See, step number 2. 34 plus, this is positive osculation process. So plus, add to this 34. What to add? 2 times first quotient, that is 6, which is equal to 34 plus 12 is 46. Now write this 46 in the row of osculation result below 34. Now divide this 46 by 9, osculator 9, which gives us quotient 9 5s are 45. Quotient is 5 and remainder is 1. 46 minus 45, remainder is 1. So write quotient 5 below 46 and write remainder 1 as a prefix to next digit, which is 4. Now read this as 14. Read this as 14. Okay, step number 3. To this 14, add. What to add? 2 times last quotient, which is 5, which gives us 14 plus 10, 24. This 24 is second osculation number and to be written below this 14. Now divide this 24 by osculator 9, which gives us quotient 2. 9 2s are 18 and remainder is 6. Correct? So write quotient 2 below 24 and write remainder 6 as a prefix to next digit in the dividend, which is 6. Now read this as 66. So friends, write these 3 steps. Okay, by pausing the video. Okay. Now step number 4. 66 plus 2 times last quotient. 2 times last quotient digit, which is equal to 66 plus 4 is 70. Now write this 70 below 66. The 70 is third osculation number and should be written in the row of osculation results, and write this 70 below 66. Now divide this 70 by osculator 9, which gives you quotient 9 sevens are 63, that is quotient is 7 and remainder is 70 minus 63 is 7. Write quotient 7 below osculation result 70 and write remainder 7 as a prefix to next digit, last digit in the dividend, which is 4. Now read this as 74. Step number 5. Step number 5. To calculate last osculation number, add to this 74, what to add? 2 times last quotient. 2 times last quotient, 7. So 7 twos are 14. 74 plus 14 is 88. So this 88 is last osculation number, last osculation result. Now friends, observe this 88. This 88 last osculation result 88 is nothing but divisor itself. Divisor itself. That means one multiple of divisor. 88 multiplied by 1 is 88. So we say 88 is one multiple of divisor, that is 88. One multiple of divisor. So quotient in this part is 1, which will be used later. Now as last osculation result is 88, it means that this number is divisible by divisor 88. 5,74,464 is divisible by 88. Now friends, let us find quotient. Quotient is 6527. 6527. Now add to this quotient, okay, which we have calculated in the last osculation result. Add this one to this quotient, which is equal to 6528, 6528, and this is our final answer. It means that 5,74,464 divided by 88 is 6,528, correct? So let us solve next example. Fourth example, 1,50,306 divided by 26. Okay, so divisor is 26. So 6 in the units place of divisor, that means we are going to use negative osculator. Okay, because we generally use negative osculator for the divisors containing 2 and 6 in its units place. Here it is 6, so let us calculate negative osculator. How to calculate negative osculator? To calculate negative osculator, we need 2 in the units place of a divisor. So let us convert this 26 into such number which contains 2 in its units place. So multiply this 26 by 2, you get how much? 26 twos are 52. 52. So 2 in the units place now. 52 minus 2 is equal to 50. Now neglect this 0 and write 5 as it is. This 5 is negative osculator. O for osculator and the sign for negation. So friends, step number 1. Let us start osculation process from left side. Consider first digit which is 1, leftmost digit which is 1. Negative osculator 5 is greater than 1, so cannot divide this one. So let us join next digit which is 5 to this 1. Now we have 15. So 15 divided by 5, which gives us quotient 5 3s are 50. Quotient is 3 and remainder is 0. So write quotient 3. in the quotient area and remainder 0 as a prefix to next digit in the dividend, which is 0. Now read this as 0. Now let us calculate first osculation number, first osculation result. So step number 2 is 0. Now friends, this is negative osculation process. So to calculate osculation number, let us subtract product of what? 2 multiplied by last quotient digit, okay, which is equal to 0 minus 2 3s are 6, that means negative 6. So write first osculation number below this 0, which is negative 6. Okay, now divide osculation number which is negative 6, this osculation number which is negative 6 by negative osculator 5, which gives us quotient negative 1 minus 1 and remainder minus 1, correct? Negative 6 divided by 5 gives quotient negative 1 and remainder negative 1. So write quotient negative 1 in the quotient area below minus 6, negative 6, which is first osculation number, and remainder negative 1 as a prefix to next digit, which is 3. Now read this as 13 with first digit 1 negative. Now first digit negative means this whole number is negative. A value of this one is 10, which is minus 10. Why minus 10? Because this is negative digit. So minus 10 plus 3, value of this 3 is 3 because it is in units place. So minus 10 plus 3, that is negative 7. Okay, this is negative 7. Now let us calculate second osculation number. See, negative 7. Okay, negative 7 minus 2 times last quotient digit, which is negative 1 minus 1. Okay, that means negative 7 minus 2, that is negative 7 minus 7 plus 2, correct? Minus 7 plus 2 is minus 5, negative 5. So write negative 5 below this negative 7. This is second osculation number. Now let us divide this minus 5 by negative osculator 5, which gives you quotient equal to negative 1 and remainder 0. Remainder is 0, correct? Now write this quotient negative 1 below negative 5 and remainder 0 as a prefix to next digit, which is 0. Now in the step number 4, let us calculate next osculation number, third osculation number. So pause the video and write these 3 steps. Okay. Step number 4, 0 minus. Do you know friends what we are doing? We are going to calculate third osculation result or third osculation number. So 0, see this 0 minus 2 times last quotient digit, which is negative 1 minus 1, which gives us minus 2, that is plus 2. This plus 2 is third osculation number. Now divide this 2 by 5. What is this 5? This 5 is negative osculator, which gives us quotient 0 and remainder 2. Quotient 0 and remainder 2. Now write quotient 0 in the quotient area and remainder 2 as a prefix to next digit, last digit, which is 6. Now read this as 26 and not as 2 and 6 separately. Step number 5. we are going to calculate last osculation number. Okay, that means last osculation result. 26 minus what? 2 times last quotient digit, which is 0 here, which gives us 26. Now write this 26 below dividend 26. Now friends, observe this 26. This 26 is divisor itself. See, divisor is 26 and last osculation result is 26. It means that given number 1,50,306 is divisible by divisor 26. This 26 is one multiple of divisor 26. It means that quotient in this part is 1. See, this quotient, this 1 is quotient. Okay, always remember this important point. And we use this quotient while calculating final answer. Let us write quotient. See, quotient is 3, -1, -1 and 0. Correct? So, but this quotient is in the form of vinculum number. So let us convert it into normal number, normal form. So how to convert? 3, 2. 9 minus 1, 8. 10 minus 1, 9. And this is 0. 2890. Okay, quotient is 2890. But friends, this quotient is for 52 and not for 26, because to calculate negative osculator we multiplied original divisor 26 by 2, suitable multiple 2, and got 52, and out of this 52 we calculated negative osculator 5. So this quotient, see, this quotient 2890 is for 52. To get the quotient, to calculate quotient for given divisor 26, we should multiply, see, we should multiply this quotient by the same multiple, which is 2. So let us multiply by 2, which gives us 200. 2 9s are 18, carry 1. 2 8s are 16 plus 1, 7, carry 1. 2 2s are 4 plus 1, 5. So 5780. Now let us add this quotient. We got this quotient in the last osculation result. So add this quotient to this quotient. So 5780, 5780 plus quotient in the last part, which was 1. Let us add this 1 to this quotient and we get 5781, 5781. This is our final answer. It means that given number 1,50,306 divided by divisor 26 is equal to 5781. Next example, fifth example, 1,55,008 divided by 56. So 1,55,008 and divisor is 56. So friends, 6 in the units place. So we are going to calculate negative osculator for the divisor. See friends, you can calculate positive osculator also. Okay, no problem. 6 in the units place. So let us calculate what we have decided. We will calculate negative osculator when we find 2 and 6 in the units place of divisor. So let us calculate negative osculator for the divisor 56. To find or to calculate negative osculator for divisor, we need 2 in its units place, but we have 6 here. So let us convert this 56 into such number which will contain 2 in its units place. That means we have to multiply this 56 by 2. So 56 multiplied by 2 is 112, that is 112, correct? So 112 minus 2, which is equal to 110. Now neglect this 0 and write 11. Okay, this is negative oscillator. 11 is negative oscillator. Now let us osculate given number, given dividend 1,55,008 by negative oscillator 11. So step number 1 is divide this 15. Why this 15? Because 1 is less than 11, so cannot be divided by 11. So join this second digit 5 to this 1. Now we have 15. So let us divide this 15 by 11, which gives us quotient 1 and remainder 4. 15 minus 11 is 4. Write quotient 1 below 15 in the quotient area and write remainder 4 as a prefix to next digit in the dividend, which is 5. Now read this as 45. Read this as 45 and let us use this 45 to calculate first osculation number. And let us write first osculation number or rest of the osculations number in this row of osculation results. So 45 minus, see this is negative osculation process, so we are going to subtract. What to subtract? 2 times first quotient, that means last quotient. See, last quotient. 45 minus 2 is 43. This 43 is first osculation number and to be written below 45, this 45. Now divide this 43 by osculator 11, which gives us quotient 3. Quotient is 3. 11 3s are 33. 43 minus 33, so remainder is 10. So write quotient 3 below 43, first osculation number, and remainder 10 as prefix to next digit, which is 0. Third step is, now consider this as 100. Read this as 100 minus 2 times what? Your last quotient digit, okay, which gives us 100 minus 6, 2 3s are 6, that means 94. This 94 is second osculation number. Now let us divide this 94 by 11, which gives us quotient 11 8s are 88. Remainder is 94 minus 88, that is 6. Remainder is 6. Now write quotient 8, third quotient 8 below 94 and remainder 6 as a prefix to next digit, which is 0. Now read this as 60 and we are going to calculate third osculation number, and that will be our fourth step. So friends, please pause the video and write these 3 steps. Okay. Yes. Fourth step, 60 minus 2 times last quotient digit, which is 8, which gives us 60 minus 8 2s are 16. So 60 minus 16. 60 minus 10, 50, 50 minus 6, 44. So write 44 below 60. This 44 is third osculation number. Now divide this 44, divide this osculation number 44 by 11, osculator 11, which gives us quotient 4 and remainder 0. So write quotient 4 below 44 and remainder 0 as a prefix to next digit, which is 8. Now step number 5. In the step number 5, we will calculate last osculation number. Okay, last osculation number, and we will write that last osculation number below last digit in the dividend. So 8, see this 8, read this as 8. 8 minus 2 times last quotient digit, which is 4, which gives us 8 minus 2 4s are 8. That means 8 minus 8 is 0. 0 below 8, and the 0 is last osculation number, last osculation result. So friends, in the last osculation result we have 0. It means that given number 1,55,008 is divisible by divisor 56. Now let us calculate quotient. See, let us write these quotient digits 1, 3, 8 and 4. 1, 3, 8, 4. But friends, 1384 is quotient for 112 and not for this 56. Okay, to calculate quotient for this 56, we will have to multiply 1384 by this 2. This 2, multiple 2, we used this multiple 2 to multiply this 56 to get 112. That means such number which will contain 2 in its units place. For calculating negative osculator for the given divisor 56. So let us multiply this quotient by multiple 2, appropriate multiple that we used. So let us multiply 1384 by 2, which gives us 2 4s are 8, 2 8s are 16, 2 3s are 6 plus carry 1 7, okay, and 2 1s are 2. 2768. See, 2768, and this is our final answer. It means 1,55,008 divided by 56 is 2768. Okay friends, so please pause video and write these steps. Okay, pause video and write these steps, and write this also. This is important point. Okay, this is important point. Multiplying quotient by same multiple which we have used to multiply original divisor to calculate negative osculator. This step is very important. Okay, don't get confused and never forget it. So friends, next example, 6042 divided by 106. So I have written already here 6042 and divisor is 106. So 6 in the units place. So let us calculate negative osculator. To calculate negative osculator, let us multiply given divisor by 2. So 106 multiplied by 2 is 212. Now we got 2 in the units place. So 212 minus 2 is 210. Neglect this 0 and write 21. Okay, neglect this 0 and write 21. Correct? This is negative osculator. Now let us osculate given number dividend by negative osculator 21. Correct? So let us start. Starting from left side, consider first digit which is 6. Step number 1. So 21 is greater than 6. So let us join the next digit which is 0. Now we have 60. So let us divide this 60 by negative osculator 21, which gives us quotient 21 2s are 42, 21 3s are 63. That means quotient should be 2 here. 21 2s are 42 and remainder is 60 minus 42, that is 18. So write quotient 2 below the 60 and write remainder 18 as a prefix to next digit in the dividend. Now read this as 184. Now let us calculate first osculation number. Step number 2, 184. See, this 184 minus what to subtract? 2 times last quotient digit, which is 2, which gives us 180. 2 2s are 4. 184 minus 4 is 180. Now divide this 180. See, let me write first osculation number. See, 180 is osculation number and should be written below this 184. Correct? 180 divided by osculator 21, which gives us 21 8s are 168. Yes, quotient is 8. 21 8s are 168. 180 minus 168 is 12. Remainder is 12. So write quotient 8 below 180 and remainder 12 as a prefix to next digit, which is 2. This 2 is last digit. It means we are going to calculate last osculation number now. So step number 3. Read this as 122. See, 122. 122 minus 2 multiplied by last quotient digit, which is 8. 122 minus 16 is 106. This 106 is last osculation number and should be written below last digit in the dividend. So friends, we have calculated last osculation number, which is 106, which is divisor itself. See, it means that given number 6042 is divisible by 106. Now 106, this osculation number, last osculation number 106 is one multiple of divisor 106. It means that this one multiple 1 is quotient. This 1 is quotient in the last part. And how do we use this quotient? We add this quotient to this quotient while calculating final answer. But first of all, we multiply this quotient 28 by multiple 2, which we have used to multiply given divisor. Why did we multiply? Because we wanted to have such number which contain 2 in its units place. Why we did this? Because we wanted to calculate negative osculator for the given divisor 106. So we multiply this divisor 106 by suitable multiple 2. So we have to, first of all, we have to multiply this quotient 28 by this 2, because this 28 is quotient for 212 and not for this 106. And we have to multiply 28 by the same multiple, appropriate multiple we used here to calculate the quotient for the divisor 106. Okay, so let us multiply. Quotient is 28. Let us multiply this 28 by multiple 2. See, this multiple. So 28 2s are 56. Now let us add this quotient to 56. and we get 57. Now this 57 is final answer. It means friends, 6042 divided by 106 is 57. Okay, 57. 2,40,592 divided by divisor 44. See, seventh example. Okay, see friends, now the divisor is 44, that is it contains 4 in its units place. See, let us read important note. Use positive oscullators for divisors containing 8 and 4 in its units places. It means friends, we are going to calculate positive osculator. Positive osculator. So let us calculate. See, to calculate positive osculator, we need 8 in the units place of that number. So let us convert this 44 into such number which contains 8 in its units place. For that we have to multiply this 44 by 2 so that we get 88. Now 8 in the units place. Okay, so we can now calculate positive osculator. So how to calculate? 88 plus 2, which gives us 90. Neglect this 0 and write 9. This 9 is positive osculator for divisor 44. Now let us osculate the given number 2,40,592 by positive osculator 9. So the first step is starting from left side. Consider first digit and divide the first digit by osculator 9. But 9 is greater than this 2, so cannot divide. So let us join second digit in the dividend, which is 4. Now we have 24. 24 divided by, divide this 24 by 9, which gives us 9 2s are 18. Quotient is 2 and remainder is 24 minus 18, 6. Correct? So let us write quotient 2. Quotient area, this is first quotient, and write remainder 6 as a prefix to next digit, which is 0. Now read this as 60, not as 6 and 0 separately. Read this as 60. I said you friend, this is similar to the gross dividend, the concept of gross dividend that we have used while studying Hatgaonkar division. So read this as 60 and we are going to use this 60 to calculate first osculation number, and it will be step number 2. Step number 2 is 60. Now as this is positive osculation process, let us add. Okay, let us add. What to add? 2 times last quotient digit. Now here last means first. 2 times last quotient digit, which is 2 here. So 60 plus 4 is 64, and the 64 is first osculation number. Now divide this 64 by osculator 9, which gives us 9 6 are 54, 9 7s are 63. So quotient is 7 and remainder is 1. So write quotient 7 below 64, first osculation number, and remainder 1 as a prefix to next digit in the dividend, which is 5 here. Now read this as 15. So step number 3, 15. See, this 15 plus what to add? 2 times last quotient digit. 2 times what is last quotient digit? 7 gives us 15 plus 14, 2 7s are 14, which gives us 29. So 29 is second osculation number and should be written below this 15. So divide this 29 by osculator 9, which gives us quotient 9 threes are 27, and remainder is 29 minus 27, remainder is 2. Now let us write quotient 3 below second osculation number, third quotient below second osculation number, and write remainder 2 as a prefix to next digit in the dividend, which is 9. Now read this as 29. Read this as 29, and we are going to use this 29 to calculate third osculation number, third osculation result. Okay, so friends, you will have to write these 3 steps first because I am going to clean it now. Please pause the video and write these 3 steps. Step number 4, 29 plus 2 times last quotient digit, which is 3 here, which gives us 29 plus 2 threes are 6, that means 35. This 35 is third osculation number, so write 35 below 29. Now divide this 35, osculation number 35, by positive osculator 9, which gives us, this is 9, okay, this gives us 9 fours are 36, that means 9 quotient is 3 and remainder is 35 minus 27, okay, that means remainder is 8. So write this 3 quotient 3, fourth quotient 3 here, and write remainder 8 as a prefix to next digit, which is 2. Yes, we have written quotient 3, fourth quotient here below 35, below third osculation number, and we have written 8, remainder 8 as a prefix to next digit, last digit, which is 2. Now read this as 82, and in the next step, that is fifth step, we will calculate last osculation number. 82, see this 82 plus 2 times last quotient 3, which gives us 82 plus 2 threes are 6 is 88, correct? So this 88 is last osculation number. Now friends, we have covered all the digits and we have calculated last osculation result, osculation number. So osculation number is 88, and this 88 is multiple of given divisor 44. It is 2 multiple of given divisor 44. See, this is divisor, okay, this is, see, 44, divisor 44. So 88 last osculation result is 2 multiple of given divisor. Now 2 multiple of given divisor, that means in this part we have quotient 2, and we will use this quotient 2 later while writing final answer. Quotient 2733 quotient digits, that means 2733. So let me write here, quotient is 2733. But friends, this is not final quotient, final answer, because this quotient is for 88 and not for 44. Why? Because we have multiplied divisor 44 by 2 to get 88. To get 88. And why did we require 88? It is because we needed such number in which there is 8 in the units place to calculate positive osculator. So the point is, we multiplied original divisor 44 by suitable multiple 2, appropriate multiple 2. So here, see, consider this 2, remember this 2. We have to multiply quotient 2733 by the same multiple 2. Now let us multiply. 2 threes are 6, 2 threes are 6, 2 sevens are 14, 2 twos are 4 plus 1 5. 5466. Now let us add this quotient. We use this quotient at last step. So quotient 2. Let us add this quotient 2 to this quotient. Okay, we get 5, 4, 6 and 8. Okay, so this is our final answer, friends. It means that 2,40,592 divided by 44 is 5,468. So friends, eighth example, 2,73,152 divided by 64. See friends, divisor is 64. There is 4 in the units place. That means we are going to calculate positive osculator. Positive osculator. But to calculate positive osculator, we need 8 in the units place. So let us convert this 64 into such number which contains 8 in its units place. So let us multiply the 64 by 2 and we get 2 4s are 8, 2 6s are 12, 128. Now we have 8 in the units place. Now 128 plus 2 is 130. Neglect this 0 and write 13 as it is, and this is positive osculator for given divisor 64. Now let us osculate given number by osculator 13. So starting from left side, consider first digit 2. Divide this 2 by osculator 13, but 13 is greater than 2. So let us join next digit 7 to this 2. Okay, now we have 27. So first step is 27 divided by 13. Osculator 13 gives us quotient. 13 twos are 26. Okay, and remainder is 1. 27 minus 26 is 1. So write quotient 2 below 27 and write remainder 1 as a prefix to next digit 3. Now read this as 13. So in the step number 2, let us calculate first osculation number. 13 plus 2 times first quotient digit. First quotient digit means last quotient digits or digit, not digits. 13 plus 2 times last quotient digit, which is 2 here, which gives us 13 plus 4, 17. Now the 17 is first osculation number, correct? So let us divide this 17 by osculator 13, which gives us quotient 1 and remainder 4. So write quotient 1 below 17, first osculation number, and write remainder 4 as a prefix to next digit, which is 1. Now read this as 41, correct? So let us, third step, read this as 41. To this 41 add 2 times last quotient digit, which is 1. So 41 plus 2, 43. This 43 is second osculation number and should be written below this 41. Now 43 divided by osculator 13. So quotient is 13 threes are 39. That means quotient is 3 and remainder is 4. So write quotient 3 below 43 and remainder 4 as a prefix to next digit in the dividend, which is 5. Now read this as 45. Now let us calculate third osculation number. But friends, please write these 3 steps by pausing video. Okay? Yes. Fourth step, 45. To this 45, add. What to add? 2 times last quotient digit, which is 3. Okay, which gives us 45 plus 2 3s are 6. That means 51. This 51 is third osculation number, third osculation result. Now divide this 51 by 13, which gives us 13 3s are 39, 13 4s are 52. Okay, that means 13 3. 13 3s are 39 and remainder is 12. 51 minus 13 3s are 39 is 12. So write quotient 3 below 51 and remainder 12 as a prefix to next digit in the dividend, which is 2. 2 is last digit. So read this as 122. Now let us calculate last osculation number, because 2 is last digit. So friends, we wrote remainder 12 as a prefix to last digit in the dividend, which is 2. Now read this as 122. Now let us use this 122. 122. To this 122, let us add. What to add? 2 times last quotient digit, which is 3. Okay, so 122 plus 2 3s are 6. That means 122 plus 6 is 128. Now this 128 is last osculation number, last osculation result, and to be written below, or should be written below, last digit in the dividend. Now friends, observe this last osculation result, which is 128, which is 2 multiple of divisor 64. Okay, see, let me write here 2 multiple of divisor 64. See, this 64 is divisor. Last osculation result is 2 multiple of divisor, given divisor. It means that, see this 2, in this part, quotient is 2, and we use this quotient in the final step, in the last step, to calculate final answer. Okay, so now friends, come here. 2133, 4 quotient digits. So let us write these 4 quotient digits here. Quotient is 2133, 2133. But friends, this quotient is for 128 and not for this 64, not for this original divisor, because we calculated this quotient, we started this process from 128. We considered this as divisor because we had to calculate positive osculator from this 128, but this is not our original divisor. 64 is our original divisor and this quotient is for 128. So let us multiply, see, let us multiply by this multiple 2. See this multiple 2. We multiplied original divisor 64 by this multiple 2 to get 128. Okay, what was the purpose? Purpose was to calculate positive osculator. So let us multiply this quotient by this multiple 2. So let us multiply, which gives us 2 3s are 6, 2 3s are 6, 2 1s are 2 and 2 2s are 4. Correct? 4 2 6 6, 4266. Now friends, last step, let us add quotient 2. What is this quotient 2? We got this quotient 2 in the last osculation result. So let us add this quotient 2 to this quotient and we get 4268, and this is our final answer, friends. It means that 2,73,152 divided by divisor 64 is 4,268. Ninth example, 30,144 divided by 24. 30,144 divided by 24. See friends, there is 4 in the divisor, there is 4 in its units place. That means we are going to calculate positive osculator for given divisor. Now to calculate positive osculator, we need 8 in its units place. So let us convert this 24 into such number which contains 8 in its units place. Now what to do? Multiply this 24 by some suitable multiple, which is 2, which gives us 24 2s are 48. Yes, now we have got 8 in the units place. We have got such number. Now let us calculate positive osculator. How to calculate? 48 plus 2 is 50. Neglect this 0. Write 5 as it is. This 5 is positive osculator for given divisor 24. Now friends, let us osculate given number, given dividend 30,144. First step is, let us start osculation process from left to right. 30. So let us divide 30 by osculator 5, which gives us quotient, of course, 6. 5 6 are 30, and so remainder is 0. So write quotient 6 below 30, okay, and write remainder 0 as a prefix to next digit in the dividend, which is 1. Now read this as 1. Now let us use this 1 to calculate first osculation number. So how to calculate? Second step is 1. See, I have written this 1 plus what to add? Why we are adding? Because this is positive osculation process. What to add? Add 2 times last quotient digit, which is 6, which gives you 2 6 are 12 plus 1 13, and this 13 is first osculation number and should be written below second digit basically, though this is third digit actually, but as we considered 30 to be divided by osculator 5, this becomes second digit. So we have written 13 below this 1, second digit 1. So first osculation number below second digit. This is second digit. Okay, consider this as second digit. Okay, now see, 13 divided by, now divide this osculation number by osculator 5. 13 divided by 5 gives us quotient 2. 5 2s are 10. 13 minus 10, remainder is 3. So let us write quotient 2 below first osculation number and remainder 3 as a prefix to next digit, which is 4, and consider this as 34. Read this as 34. Now let us calculate second osculation number. Third step, 34. See, this 34 I have written here, plus 2 times last quotient digit, which is 2, which gives us 34 plus 4, 38, and this 38 is second osculation number. Now divide this 38, second osculation number, by osculator 5, which gives us quotient 5 7s are 35, and remainder is 38 minus 35, remainder is 3. So let us write quotient 7 below 38 and remainder 3 as a prefix to next digit, which is 4. Now read this as 34. Read this as 34. Now friends, let us calculate last osculation number. So friends, please pause the video and write these 3 steps. Okay. Step number 4. 34 plus, see friends, we are calculating last osculation number. Okay. So 34 plus 2 times last quotient, which is 7 here, which gives us 34 plus 14. 2 sevens are 14. That means 48. So write 48, last osculation number 48 below last digit in the dividend, which is 4. Now see friends, we have covered all the digits and we have calculated last osculation number result, which is 48. Now see friends, this 48 is 2 multiple of given divisor 24. Correct? Do you see this? Divisor is 24 and this 48 is 2 multiple of divisor 24. This is divisor. It means that, see, what is multiple? 2. Then the multiple is quotient. See, quotient is 2. Quotient in the last osculation result. 48 is last osculation result and we got quotient 2 in the last osculation result. Why? Because last osculation number, last osculation result is 2 multiple of given divisor 24. That means 2 multiple, that means quotient is 2 here. Now let us find quotient. See, 3 quotient digits, 6, 2 and 7. Let us write it. Quotient 6, 2 and 7. But friends, this quotient is for this 48 and not for this 24. We calculated, we got this 48 because we multiplied original divisor 24 by 2. Okay, multiple is 2. And we got 48. What was the purpose? Because we wanted to calculate positive osculator, and to calculate positive osculator we needed 8 in the units place. So we converted original divisor 24 into 48, and while converting that we multiplied original divisor by 2. Multiple was 2, so obviously you have to multiply this quotient by 2. Correct? So let us multiply. 2 sevens are 14. Write 4, carry 1. 2 twos are 4 plus 1 5. 2 6 are 12. Okay, 1254 is quotient, but it is not final answer. Add this 2 to this quotient. So plus 2, which becomes 1256. Okay, so this is our final answer, friends. 30,144 divided by 24 is 1256. 10th example, 31,044 divided by 12. Divisor is 12. There is 2 in the units place of divisor. It means that we are going to calculate negative osculator for given divisor. So let us calculate negative osculator. Write this divisor as it is. Minus. See friends, to calculate negative osculator, we need 2 in the units place, which we already have. So no need to multiply this by any multiple. So 12 minus 2, which gives us 10. Neglect this 0 and write 1 as it is. This 1 is negative osculator. Now let us osculate given number by negative osculator 1. Okay, so first step is consider first digit, which is 3, from left side. Why? Because we start the process of osculation from left to right. Okay, now consider first digit, which is 3. divide this 3 by negative osculator 1, which gives us quotient 3 and remainder 0. So let us write quotient 3 below first digit 3, and let us write remainder 0 as a prefix to next digit, which is 1. So next step is this 1. Consider this 1. What we are doing? We are going to calculate first osculation number. So 1 minus what to subtract? Why to subtract? Why to subtract? Because this is negative osculation process. Therefore, subtraction. What to subtract? 2 times last quotient, which is 3. Okay, which gives us 1 minus 6, that is minus 5, negative 5. Okay, now this negative 5 is our first osculation number. Now let us divide this negative 5 by osculator 1, which gives us quotient negative 5 and remainder 0. So write quotient negative 5 minus 5 below osculation number minus 5, and write remainder 0 as a prefix to next digit in the dividend. Now next step is 0 minus what to subtract? 2 times last quotient digit, which is negative 5, which gives us 2 5s are 10, 2 5s are 10, that is minus 10, minus minus 10, that is plus 10. So this plus 10 is second osculation number. Now let us divide this second osculation number by osculator 1, which gives us quotient 10 and remainder 0. Quotient 10, third quotient digit, okay, should be written below this second osculation number, and write remainder 0 as a prefix to next digit in the dividend, which is 4. So friends, please write these 3 steps by pausing the videos. Fourth step, read this as 4. We are going to calculate third osculation number. See, 4 minus 2 times last quotient, which is 10, which gives us 4 minus 20. See, 4 minus 20 minus 16, negative 16. Okay, now this negative 16 is third osculation number and should be written below this 4. So divide this negative 16 by osculator 1, which gives us quotient negative 16 and remainder 0. So let us write quotient negative 16 minus 16 below third osculation number minus 16, and write remainder 0 as a prefix to next digit in the dividend, which is 4, last digit. So let us find last osculation number. So 4, see this 4, I have written here this 4, okay, minus 2 times last quotient, that is negative 16, which gives us 16 2s are 32, that is minus 32. 4 minus minus 32, that means 4 plus 32, which is 36. Correct? 36. This 36 is last osculation number and should be written below last digit in the dividend. So friends, see this 36. This 36 is 3 multiple of divisor 12. 3 multiple of divisor 12. 36 is 3 multiple of divisor 12. It means, friends, in this part we got the quotient 3. See this multiple is quotient. Okay, so quotient is 3 in this part. Okay friends, now let us find quotient. Okay, to find quotient, let us write these 1, 2, 3 and 4 quotients. See friends, please don't get confused. Although we didn't draw lines, but see, these are the parts, you know. See if I draw line like this, if I draw lines like this, okay, see, these are the parts friends, correct? First part, second part, third part, fourth part, fifth part. Fifth part is last part. In the last part we wrote last osculation result, and see, in each part we wrote quotients. Okay, so friends, tell me, in every part there can never be quotient more than one digit. It is not possible except leftmost part. Okay, understand it. Except leftmost part, there can never be quotient in the form of more than one digit. In the form of more than one digit. It means that we have extra digits in these parts, means in this part and this part. So let us transfer that extra digit to its immediate left. Okay, so let us write here, quotient is 3, -5, 10 and -16. See here. See friends, leftmost digit or digits are considered to be extra digits. Okay, so see here, this is an extra digit. So let us transfer to its immediate left. So 10 plus -1, that is 9. Correct? So let us cancel this and we will write 9 here, and we will write only 6 here because we have already transferred this one to its left. Okay, so let us write 3, -5, 9 and -6. Okay, but this is vinculum number, no problem. Let us convert it into normal number. So 2, 5, 8 and 4. Okay, 2, 5, 8, 4. Now let us add quotient in the last part, which is 3, to this quotient. Okay, you get 2, 5, 8 and 7. Okay, 2, 5, 8, 7, 2587. Okay friends, see, this is our final answer. It means friends, 31,044 divided by 12 is 2587. Okay, so next example, 28,44,292 divided by 62. See, divisor is 62. There is 2 in the units place. It means that we are going to calculate negative osculator for this divisor. So let us write 62. How to calculate negative osculator? Subtract 2, which is equal to 60. Neglect this 0 and write 6 as it is. The 6 is negative osculator. To calculate negative osculator, we need 2 in the units place of given number, given divisor, which we already have here. So we calculated negative osculator. Now, osculation process starting from left side, 28. Now let us divide 28 by negative osculator 6, which gives us quotient. 6 4s are 24. That means quotient is 4. And remainder is 4. Correct? 28 minus 24, remainder is 4. So let us write quotient 4 below 28, and let us write remainder 4 as a prefix to next digit. Now read this as 44. With this 44, let us calculate first osculation number. How to calculate? See, See, second step, write this 44. Now subtract 2 times 4. 2 times 4 means 4 is last quotient digit. Subtract 2 times last quotient digit from this 44 and you get, why we are subtracting? Because this is negative osculation process. In the positive osculation process we add to this dividend, and in negative osculation process we subtract from this dividend to get osculation result. 44 minus 8 is 36. This 36 is first osculation number and to be written below this 44. Now let us divide this 36 by negative osculator 6, which gives us quotient 6 and remainder 0. So let us write quotient 6 below 36 and remainder 0 as a prefix to next digit, which is 4. Now read this as 4. So let us use this 4 in third step. 4 minus 2 times last quotient, 2 times last quotient 6. So 4 minus 12, 2 6 are 12. 4 minus 12, it is negative 8. This negative 8 is second osculation number. Now divide this negative 8 by osculator 6, which gives you quotient negative 1 and remainder negative 2. Which should be written, see, quotient negative 1 should be written here in the quotient area, and negative 2, remainder negative 2 should be written as a prefix to next digit, which is 2. Now this is 22 with first 2 negative. That means this number is negative. See, the value of this minus 2 is minus 20 and value of this 2 is plus 2. Minus 20 plus 2 is negative 18. See, this is tens place. Okay, so negative 20 and this is units place, so positive 2. So negative 20 plus positive 2, negative 18. Correct? Negative 18. So let us use this negative 18 to calculate third osculation number. So friends, please write these 3 steps by pausing the video. Okay. Step number 4. Negative 18 minus what to subtract? 2 times last quotient. 2 times last quotient, which is negative 1. Okay, so 2 multiplied by negative 1 is negative 2, minus 18 minus minus 2, that means minus 18 plus 2, that is negative 16. This negative 16 is third osculation number and should be written below this 22 or this negative 18. So let us divide this negative 16 by osculator 6, which gives us quotient, see, negative 2 and remainder is negative 4. See, 6 multiplied by minus 2 is minus 12. Minus 16 minus minus 12 is minus 16 plus 12. That means remainder is negative 4 minus 4. Okay, so let us write negative 2 as a fourth quotient and negative 4, remainder negative 4 as prefix to next digit, which is 9. Now read this as 49 with first digit 4 negative. So first digit is negative, higher place digit is negative, that means whole number is negative. The value of this negative 4 is negative 40 and value of this 9 is 9. So minus 40 plus 9 is minus 31. Let me change color. Negative 31 minus 31. So let us use this minus 31 in the fifth step. Minus 31 minus 2 times last quotient, which gives us minus 31 minus minus 4, that is minus 31 plus 4, which gives us minus 27, negative 27. Now write this negative 27 as fourth osculation result. Now divide negative 27 by 6, which gives us quotient. 6 fours are 24, that means negative 4 minus 4, and remainder is minus 3. Write quotient below this minus 27 and write remainder minus 3 as a prefix to next digit, which is 2, last digit 2. Now read this as 32 with first digit negative. First digit negative means whole number is negative. What is that number? 28. Write minus 28 here. Okay, value of this number is minus 28. So let us use this minus 28 to calculate last osculation result. So minus 28 minus 2 times last quotient digit, which is minus 4, negative 4, okay, which is equal to minus 20. This minus 20 is last osculation result. Minus 20, minus 20. This minus 20 is not divisor itself and is not multiple of divisor. It means that given number 28 lakhs 44,292 is not divisible by given divisor 62. See, not divisible. Okay, not divisible. But even if it is not divisible, we can find quotient and remainder definitely. See, if given number is not divisible by given divisor, then last osculation result is nothing but remainder. So friends, this is remainder. This negative 20 is remainder. Now let us find quotient. See, let us write this quotient digits first. Let me select green color. Okay, see, quotient is 4 6 minus 1 minus 2 minus 4. Okay, 3 digits negative. This is vinculum number. Now let us convert this vinculum number into normal number, which gives 4 5. Now all from 9 and last from 10. So 9 minus 1 8, 9 minus 2 7, and last digit 10 minus 4, that is 6. So 45,876 is quotient and remainder is negative 20. That means we can write in this form. See, what is dividend? 28 lakhs 44,292 is equal to what is quotient? Sorry, what is divisor? 62. Right, am I right? Yes, divisor is 62 multiplied by, right, quotient 4 5 8 7 6, that means 45,876 plus remainder negative 20. Now friends, you can calculate this and you will find that both sides are equal. Okay, both sides are equal and we are correct. So friends, last example, 12th example is 2,37,692 divided by 52. Divisor is 52. 2 in the units place. So we are going to find negative osculator. We need 2 in the units place to find negative osculator, which we already have. So no need to do anything, means to multiply by some suitable multiple and so on. So 52 minus 2 is equal to 50. Neglect the 0 and write 5 as it is, and this is negative osculator. Now let us osculate given number by this negative osculator 5. So step number 1. Step number 1. Consider first digit 2. Let us divide this 2 by 5, but 5 is greater than 2. So join next digit 3 to this 2. We have 23 now. Let us divide 23 by 5. Okay, which gives us quotient 5 fours are 20, remainder 3. So write quotient 4 below 23 and remainder 3 as a prefix to next digit, which is 7. Read this as 37. Step number 2. 37. You cannot divide 37 directly. For that you have to calculate osculation number, and then you can divide osculation number. So let us find osculation number from this 37. How to find 37? Subtract. What to subtract? 2 times last quotient digit, which is 4. Yes. 37 minus 8 is 29. This 29 is first osculation number, and write this 29 below dividend from which this osculation number has been calculated. So let us write this 29 below this 37. Now divide 29 by osculator 5, which gives you quotient. Quotient is 5 and remainder is 29 minus 25, remainder is 4. So write quotient 5 below 29, that is first osculation number, and write remainder 4 as a prefix to next digit in the dividend, which is 6. Now read this as 46. Next step, let us use this 46 to calculate second osculation number. How to calculate? Subtract from this 46, subtract 2 times last quotient, which is 5, which gives you 46 minus 10, 36. 36 is second osculation number. Now divide this 36 by osculator 5, which gives you quotient. See, 5 sevens are 35, quotient is 7 and remainder is 1. Write quotient 7 below 36, second osculation number, and write remainder 1 as a prefix to next digit, which is 9. Now read this as 19, and let us use this 19 in the fourth step. So friends, please pause the video and write these 3 steps. Okay. Fourth step, 19. Write this 19. Subtract. What to subtract? 2 times last quotient 7. So 19 minus 2 sevens are 14 is 5. Write this 5 below 19. This 5 is third osculation number. Now divide this 5 by osculator 5, which gives us quotient 1 and remainder 0. So let us write quotient 1 below this 5 and remainder 0 as a prefix to next digit 2. Write this 0, remainder 0 as a prefix to next digit, last digit in the dividend, which is 2 here. Now read this as 2 and let us use this 2 to calculate last osculation number. 2 minus 2 times last quotient 1, which gives us 0. 2 minus 2 is 0. So let us write this 0 below. Let us write this 0, last osculation number 0, below last digit in the dividend. Now friends, we have covered all the digits and we have calculated last osculation result, which is 0. Last osculation number result is 0. That means given number, given dividend 2,37,692 is divisible by given divisor 52. So friends, let us now find quotient. Quotient is 4571. Write 4571 as it is. Okay, so this is how divisibility is checked for even divisors, friends. Very beautiful method and very much useful method.